So now I would like to discuss set in Python. So the first point is set is represented using curly brackets. And the second point is set is a unordered collection of items. The first one is a set is represented using curly brackets. So these are the brackets we have used to represent set in Python. And set is a unordered collection of items. That means in which way you have inserted the elements, you may not get the output in the same order. The order may change. That's why it is unordered collection of items. So insertion order does not preserved. And third one is a So third point is set is a mutable. The whole set is a mutable. That means we can change the elements in the set. We can change the elements in the set. We can modify, we can add, we can delete. All these operations can be done in the set data structure. But set items are immutable. So set items are whatever individual elements are immutable. But whole as a set we can change. That is nothing but a mutable property. And next one is set is a collection of heterogeneous items. That means we can store different types of items. That means we can store integer, we can store a floating point values, we can store string values. Any type of data can be stored in a set data structure. And next one is a and fifth one is slicing and indexing is not allowed. So in set data structure, slicing index is not possible. Why it is not possible? Because set is a unordered collection of items. That means the order is in which way you are inserted, you may not get the order in the same order. That's why indexing and slicing is not possible in set data structure. And sixth one is sixth point is duplicates are not allowed. In set data structure, we cannot duplicate the items. So the items in the set are unique only. Duplicate items are not allowed in set data structure. So these are some of the properties of a set data structure in Python. Set is represented using curly brackets, and set is unordered collection of items. And set is immutable. The whole set is immutable, but the items in the set are immutable. And set is a collection of heterogeneous items. So it is a collection of different data items. And slicing and indexing is not allowed. And duplicates are not allowed. Duplicates are not allowed. So these are some of the properties of set in Python. So next one is how to create a set in Python. Suppose I have written S equal to curly brackets. Because set is represented using curly brackets, I want to represent empty set. Suppose I have written S equal to brackets, is it correct to represent empty set in Python? So this is a not a valid empty set in Python, because if you represent S equal to curly brackets, the interpreter treats that it is a dictionary. It is a dictionary. So this is not a way to represent empty set in Python. Suppose I want to represent empty set in Python, then what we have to do? We have to do S equal to set, like this you have to represent. So this is a method to represent set in Python. So S equal to set brackets you have to use. If you use like this, suppose I will write print S, then you will get output is empty set in Python. So this is a way to create empty set in Python. Suppose I want to create another set with set of integers. Then you have to use 10, 20, 30, 40. How many elements you want? You can represent. So S1 is another set consisting of 4 elements. 4 are integers. Suppose I will write print S1, you will get the output 10, 20, 30, 40, you will get the output. Suppose I want to represent another set with heterogeneous items, because set is a collection of heterogeneous objects. That's why I want to represent S2 equal to, suppose 1, 2, 3, 4 BIT. Like this also you can represent in Python. So S2 is a collection of heterogeneous items. S is a set collection of heterogeneous items. This is the item 1, this is item 2, item 3, item 4. Like this we can represent 4 items, collection of different items in a Python as a set S2. Suppose I want to represent another set S3 equal to, suppose I have written 1, 2, 3, 2, 4, 3, 5. I have taken elements, 7 elements, 1, 2, 3, 2, 4, 3, 5. Suppose I want to print S3. I want to print S3. I have given print S3. So what is the output you will get here? So in this case you will get the output. So 1, 2, 3, 4, 5 you will get the output. You will get the output 1, 2, 3, 4, 5 only you will get the output. Why? Because set does not allow duplicate values. Previously we discussed set does not allow duplicate values. Suppose if you represent duplicate values in the set, it will consider only unique value. That means if you represent 2 times, it will consider only 1 time. So suppose here we represent 3 2 times, but it will consider only 1 time. Second time it is not allowed. So what is the output you will get? 1. You will get the output 2, 3. 2 is already represented. So this is not allowed, and 4 is allowed, and 3 is already represented, 3 is not allowed, 5 is allowed. So what is the output you will get? 1, 2, 3, 4, 5 you will get the output. So 2 points we have discussed here. One is it is a collection of heterogeneous items. Yes, it is allowed, and it does not allow duplicates. It does not allow duplicates. So if you represent duplicates will be removed if you print the set with duplicate values. Okay. So this is a way of creating set in Python. And also, suppose I want to represent another set. For example, S5 equal to, you can also write 1, 2. Suppose S5 equal to set of 1, 2. So you can also represent like this. S5 equal to set of list of values. That means list consisting of 1, 2. Then suppose I will write print S5. So what is the output you will get? You will get the output 1, 2. You get the output 1, 2. You will get the output. Suppose consider another set. For example, S6 equal to, suppose I am writing set of 1, 2, 3. Suppose I represent like this. S equal set of 1, 2 comma 3. This is not allowed in Python. Why it is not allowed? Because 1 is allowed, but 2, 3, it is nothing but a list. List is actually, it is mutable. List is actually mutable. But what is the point we have discussed? Set items must be immutable. Set items must be immutable. So the item cannot be represented as a list. The item cannot be represented as a list. If you represent like this, you will get a error. Suppose if you represent S6, print S6 means you will get a error, because list is not allowed as a set item, because set item is a immutable, but list is here mutable. That's why it is not allowed. Okay, so this is the way of creating set in Python. This is the way of creating empty set. This is the way of creating set with integer values. This is the creating set with heterogeneous items. That means multiple items you can represent in a set. And this is the way of deleting duplicate items, because set not allowed duplicates. And we can also represent list items as a set items. And another one is a individual set item cannot be represented as a list. So these are the way of creating set in Python. Now we have seen how to create a set in Python. Now we'll see how to modify the set elements in Python. How to modify the whole set. We already know we can change the set is a mutable. That means we can change the elements in the set data structure. Suppose I created S equal to 1, 2, 3, 4. Suppose I want to add another element into this set S. Suppose I want to add another element. Simply you can write S dot add of 5. S dot add of 5. Then suppose I have print S. Print S means you get the output 1, 2, 3, 4, 5. You get the output. So you can add an element by using a method called add. Using this add method, we can add only single element. We can add only a single element by using this add method. Suppose I want to add multiple elements, then you have to go for update method. Then you have to go for update. Suppose S is consisting of 5 elements. Now I want to add another 2 elements. Then you have to use S dot update. S dot update of, you can use 6, 7. You can use 6, 7. Then suppose I will write print S. What is the output you will get? You will get the output 1, 2, 3, 4, 5, 6, 7. You will get the output. Suppose if you want to add a single element, then you have to use the add method S dot add. Suppose you want to add multiple items, then you have to use S dot update method. So these are the two methods available in Python to add elements or modify the existing set by using these two methods. And next one is, suppose I want to remove the elements, remove the items from the set data structure. Suppose consider S equal to 1, 2, 3, 4. Now I want to remove 4. Suppose I have written S dot discard. S dot discard of 4. Then suppose print S. What is the output you get? You will get the output 1, 2, 3. You will get the output. Suppose another method is there. I want to remove S dot remove of 3. Suppose print S. So what is the output you will get? 1, 2 you will get out. So here you see discard means a particular element can be removed by using discard method. Suppose I want to remove a particular element. Suppose I want to remove 4. Then S dot discard of 4 means 4 will be removed. Then you will get the output 1, 2, 3. Suppose I want to remove 3. So S dot remove means 3. S dot remove of object. Suppose I give in 3. Print S means you get the output 1 and 2. So these two are looking same. Like that only. This is also for removing a particular element. This is also for removing a particular. Then what is the difference between discard and remove? Suppose in this case I have given S dot discard of, suppose 50 I have given. S dot discard of 50. 50 is not available in S set. So what is the output you'll get? You won't get any error in the case of discard. For in the case of remove, suppose S dot remove of 50, suppose I have given, then you will get an error. You will get a error. So that is the difference between discard and remove. So discard means if the item is not available in the set data structure, you won't get any error. But in the case of remove, the particular object is not available in a particular set, yes, then you will get a error. So that is the difference between discard and remove. Apart from these two, another method is also available, that is called pop method. That is called a pop method. Suppose I have written S dot pop. S dot pop. Suppose print S. I given. So what is the output you will get? You will get the output is 1. S dot pop means it will delete randomly, it will delete a particular element because it is not a collection of items. So which item is deleted? Generally we don't know, but actually it will delete the last element. Generally it will delete the last element. So last element is 2 here. S dot pop means 2 will be deleted. Print S means you will get only 1, you will get the output. So randomly if you want to delete a particular item from the set, then you have to use S dot pop method we have to use. So these are the, we can also store the deleted element into a particular variable. We can also print that particular variable. So these are the three methods available to remove a item from the set data structure. One is called discard, another one is called remove, and next one is called pop. So discard is a particular object can be removed. If the object is not available, you won't get any error. But S dot remove method, you will get an error in the remove method. And pop means randomly it will delete a particular object from the set data structure. So these are the methods available in Python. Next one is copying set in Python. How copying will be done? Set in the set data structure in Python. So here there are two methods are available. So what is the difference between these two methods? We will see with examples. The first one is equal to operator. We can also copy one set into another set by using equal to operator, that is method 1. And we can also copy by using copy method. By using a copy method, this is another method is available in set data structure. The first one, first you will see equal to operator. It is just like copying one variable into another variable. Just like that only, we can copy one set into another set. Suppose I have taken S1 equal to 1, 2, 3, 4, 5. I have taken S2 equal to S1. S2 equal to S1. If A equal to B, in that case what will happen? B is also pointing to A only indirectly. Because an object will be, suppose A equal to 10. After that, suppose I have written A equal to 10. B equal to A, then what will happen here? So 10 object will be created. A is pointing to 10 and B is also pointing to 10 only in the case of ordinary variable. Same is also apply for set also. That means here you see one set is created with values 1, 2, 3, 4, 5 and S1 is pointing to that particular set. Suppose I written S2 equal to S1, that means S2 is also pointing to S1 only. S2 is pointing to same location only. S2 is also pointing to same location. Now S2 dot add of 6. S2 dot add of 6. I want to add another element. Then it will add in the another element. So now print S2 means what is the output you will get. Print S1 means what is the output you will get. Suppose here you see print S2 means what is the output you get? 1, 2, 3, 4, 5, 6. Print S1 means what is the output you get? In this case also you get the output 1, 2, 3, 4, 5, 6 only you get the output. So what is the output you get? 1, 2, 3, 4, 5, 6. Print S2 means, and print S1 means also 1, 2, 3, 4, 5, 6. You will get the output. So in the both the cases you will get the same output. In the both the cases you will get the same output. That means if you change, if you modifying S2, S1 is also modifying. Similarly, if you modify S1, S2 also will modify automatically because both are pointing to same set only indirectly. But I don't want like this. I want to separate S1 and S2. Then we have to go for a method called copy method. This is the method we have to use. This is called a copy method. In this case, what will happen? The syntax is a particular set dot copy. This is the method we have to follow. Copy is a method, and for this method is applying for which set? That set name we have to specify here. So set dot copy. This is the syntax. Suppose I have taken S1 equal to 1, 2, 3, 4, 5. Now I have written set S2 equal to S1 dot copy. S1 dot copy. That means whatever elements in the S1 that will be copied to S2. That means S1 will contain 1, 2, 3, 4, 5. So this is pointing to S1, and another set called S2. 1, 2, 3, 4, 5, consisting of 5 elements. S2 is pointing to another set. Two different sets will be created. S1 is pointing to one set, S2 is pointing to another set of same, because S1 is copied to S2. Even though items are same, but locations are not same. But in the previous case, both are pointing to same location, but here S1 S2 pointing to different location. Now S2 dot add of 6 means in S2 another element we added here. So 1, 2, 3, 4, 5, 6 will be added in S2. Print S2 means what is the output you'll get? You'll get the 1, 2, 3, 4, 5, 6, you'll get the output. Print S1 means you'll get the output 1, 2, 3, 4, 5 only you'll get the output, because both are pointing to different locations. In S2, if you are updating S2, updated value you get in the S2 only, you won't get in the S1, because both are pointing to different locations. But in the previous case, both are pointing to same location. That's why if you add one element in one set, both will be pointing to same location. That's why you will get the same output. But if you want to different output, if you want to get, then you have to go for set dot copy method. Set dot copy method. So these are the two methods available. But in this case, both are pointing to same location. But in the copy method, both are pointing to different locations. So this is the copying set in Python. And next one is built-in function. What are the built-in functions available in set data structure in Python? One is called all, is one built-in function. Any is another function, and length len is another function. Max and min and sorted. These are the built-in functions available in set data structure. All means if all the elements in the set are true, then you will get the output true only. If the any means if any of the particular element in the set is true, then you will get the output is true. Otherwise, you will get the output is false. Length means it will count number of items available in the set data structure. Max is to find the maximum element in the set, and min is to find the minimum element in the set, and sorted is to sort the elements in the set data structure. So these are the 6 built-in functions available in set data structure. We will see one by one. So first one you will see, suppose S consisting of 1, 2, 3 elements, 3, 4, 5. How many elements you want you can create. Suppose S is created with 5 elements. Now I want to print all of S. So what is the output you will get? If all are true, then you will get the output is true. Here 1 is true, 2 is true, 3, 4, 5, all are true only. If you are having any element 0, then you will get the output is false. But if all the elements are if all the elements in the set are not having 0, that's why you will get the output is true. So next one is any. Suppose S equal to 0, 1, S1 equal to 0, 1, 2, 3. Suppose any of S1. Suppose I will print any of S1. Here also you have to give print. Print means it will print the output. So here print any of S1. That means if any of the element is true, then you will get the output is true. Here this is false, but this is true. So if any one of the element is true, you will get the output is true. So in this case also you will get the output is true. Next one is to find the length of a particular set. Suppose I want to print length of S1. I want to print length of S1. S1 consisting of how many elements here? 1, 2, 3, 4 elements. That will get the output is 4. Next one is, suppose I want to print max of S1. Max of S1. That means it will find the maximum element in the set S1. So what is the maximum element here? 3 is the maximum element. So you will get the output is 3. Suppose I want to print minimum element. So print min of S1. Min of S1. What is the minimum element here? 0 will get the output. So these are the all any length, min and max. And next one is a sorted is a another one. This is a function to sort the elements in the set. Suppose set consisting of 6, 3, 4, 1, 2. Now I want to sort the elements in the set data set. Yes, then you have to use print sorted of yes. Sorted of yes means what is the output you will get? You will get the output 1, 2, 3, 4, 6. You will get the output. Suppose I will give print yes. So what is the output you will get? So you will get 6, 3, 4, 1, 2. You will get the output. That means sorted function just you will apply for the S set. You will get the output in sorted order. But original S may not be sorted order. Original S may not be sorted order. Only this is for sorting the element. To display the elements in sorted order, then we have to use a sorted built-in function is used. So these are the built-in functions available in set data structure. So next one is set operations in Python. These mathematical operations we can operate on set data structure in Python. The first operation is union operation. This is a symbol to represent union, and this is intersection operation, and this is difference. This is symmetric difference. All these are 4 set operations we can done in Python. So the first one is union. Suppose I have taken the set A equal to 1, 2, 3, 4, B equal to 2, 3, 4, 5. Now I want to print A dot union of B. A dot union of B. You already know what is a union. Suppose I represent like this. Union of A, print A dot union of B. That means what is the output you will get here? So what are the here common elements are 2, 3, 4. So A dot union of B means you will get the output. So 1, 2, 3, 4, 5. Just it will eliminate duplicates. Just it will eliminate the duplicates. Then 2 is containing both, so it will take only 1, 2. 3 is also it will take 1, 3. 4 also it will take only 1, 4. So what is the output you will get? 1, 2, 3, 4, 5. You will get the output. So this is the union. And next one is suppose print A dot union of B C D. That means I want to combine A and B C D. All these 4 I want to combine. So A union means you will get 1, 2, 3, 4, 5. Here 3, 4, 5 already existing. Here 6 is another element. And in C, in D, what is another element? 7 is another element. So what is the output you will get here? In this print A dot union of B C D means you will get the output 1, 2, 3, 4, 5, 6, 7 you will get the output. So union means you will combine A, B, C, D. That means you can also represent A colon A, the symbol B, and combine C, combine D. You can also write like this also to combine all the sets. A, B, C, D, 4 sets I want to combine. You can also represent like this. Otherwise, you can also write print A dot union of B, C, D. Union of B, C, D. Also, you can write both are same. In the both the cases, you get the output 1, 2, 3, 4, 5, 6, 7 is the output if the input is like this. So this is the union operation. Next one is intersection operation. Print A dot intersection of B, C, D. Intersection means you already know common elements. So what are the common elements in A, B, C, D? So here in A union B means you will get the common element 2, 3, 4. here in these two you'll get the 5 is a common element, 6 is a common element, 4, 5, 6 is common element. So in these, out of all these, here you will get the output. If you combine A, B, what is the common elements? 2, 3, 4 is the common elements. And suppose CD, what are the common elements is 4, 5, 6. 4 is already existing. So what are the common elements? 2, 3, 4, 5, 6 you will get the output. 2, 3, 4, 5, 6. Two, three, four, five, 6 is the 6 is not available here. So you have to 6 also you won't get. Here you see 2 is available, 1 is available only in A, 2 is available A, B, and C, D is also not available. 3 is available in A, B, and C is available in C is also D is not available. 4 is available in A, B, and C, D. So 5 is not available in A, 6 is not available in A, B, 7 is not. So what is the common element here? 4 is the common element. 4 is the common element out of all these 4 sets. So common elements we can get by using intersection operation. So 4 is the, or because 4 is available in A, B, C, D. All these 4 sets combined consisting of common element is only 4. That's why you'll get the output is 4. Suppose print A dot intersection of B. That means I want to combine only A and B. So what are the common elements here? 2, 3, 4. So what is the output you'll get in this case? 2, 3, 4 you'll get the output. So A dot intersection of B. You can also write A dot intersection of B, comma C, comma D. You can also combine 4 sets. And also you can use intersection symbol. You can also write print of. You can also write print of A intersection B intersection C intersection D. You can also write like this, print A intersection B intersection C intersection D. Then also you will get the output is 4. Only set consisting of only one element, that is 4. So these are the union and intersection. Next one is a difference. That means A minus B. You already know difference is nothing but what are the elements which are does not exist in B and also not a common element, but it should contain in A. So A, this is the A1, C1, 100, 200, 300, 400, A1, 1, 2, 3, 30, 300, B1, 10, 20, 30, 40. Print A dot difference of B1 comma C1, and also you can write print A1 minus B1 minus C1. Symbol also you can represent in this case. What is the output here? You will get A1 minus B1. Suppose I want to first calculate A1 minus B1. What is the output? You will get A1 minus B1. So here 100 A1 minus B. This is A1 and this is B1. 1 is not available in B. So 1. 2 is not available in B. So 2. And 3 is not available in B. So 3. Next 30 is available in B1, 300 is not available in B1. So what is the output we got here? This is the A1 minus B1. Now I want to total A1 minus B1 minus C1. Now we have to see, we have to take C1 is 100, 200 and 300 and 400. So what is the output between this A1 minus B1? You got the output this one minus C1. So what is the output you'll get? 1 is not there in C1, so 1 you'll get. 2 is not there, so 2 you'll get. 3 is not there, so you'll get the 3. 300 is common, so we should not take common elements. So this is the output we got, A1 minus B1 minus C1. We'll get the output. And next one is last one is symmetric difference. Symmetric difference. Suppose A2 equal to 1, 2, 3, 4, 5 and B2 equal to 10, 2, 3, 4, 50 and C equal to 1, 50, 100. So A symmetric difference, B symmetric difference, C, and also what is the output you will get in this case? You will get the output 100, 5, 10 you will get the output. 100, 5, 10 you will get the output. So this is that means here A2, B2, C2 we have taken, that's a print A2 and B2, C2 you have to take here. A2, what are the sets you have taken? Same variable we have to use here, frame object. A2 symmetric difference B2, symmetric difference C2. So what is the output you got here? 100, 5, comma 10. So this is the 100. Here see A2 symmetric difference B2. What is the output you will get? So what are the non-common elements? What are the non-common elements here? 1 is not available here. So 1. Next 2 is common, 3 is common, 4 is common, 5 is not common. So 5 and 10 is not in A2. So 10, comma 50 is not in A2. So 50. Now we have to make symmetric difference for C2. So what is C2 here? 1, comma 50, comma 100. So now again what is the output we got? So 1 is common in both and 5 is not common. So 5 we have to take and 10 is not common. So we have to 10 and 50 is common. 100 is also not common. So what is the output we got here? 5, 10 and 100. So 100, 5, 10, that is the output we got. Symmetric difference between A2, B2 and C2. So these are the set operations available in Python. Thank you.